That's cool. That's butter, huh?
It is. Because I can't believe it's not JavaScript, but butter.
Oh, wow. Do you work in marketing? Because that's awesome. We have time for a couple questions. If you have them, Slido, react.paris/Slido. There we go. There's already a few. We can take maybe 2 or 3. Let's start with Rodi. Can we bring that back?
I was going to say, if you didn't have any questions, just meant I did a great talk, but then I saw the questions.
Okay, so Rodi wants to know, how does the theme switcher example work with server rendering?
Yeah, so like I said, the reason the theme switcher is great for React is because React kind of works as a single page application, meaning that it's only checking for the input. If you reload the page, the input reverts itself, so the theme switcher wouldn't work. But like I said, that's why you have JavaScript for functionality. So what you should be using your JavaScript for is when the user clicks it, you're going to store their option in local storage, and when the page is reloaded, you just call that value from local storage and update your theme switcher. So I'm not saying you shouldn't use JavaScript for theme switcher. I'm just saying for the actual color toggling, only use CSS.
Very good, very good. There's a question. They're choosing questions, but I'm going to choose my own. Because there's a question here by Alexandre. That is a very good one. Can we affect other elements styled when a popover is opened? Meaning, if you open a popover, can you blur the background?
That is a great question. Actually, do I have time to show that real quick?
Ooh.
If I could, what's this? Where my slides go? Where's my well,
they can bring it back. They can look at them. They're panicking back there. There you go.
Yeah, I keep you on your toes. All right. So if we take a look at this element here, can you guys notice that the background is a bit blurred?
Oh yeah.
That is using a feature called backdrop. Oof. So backdrop is another included feature with popover, which allows you style the overlay itself. So if I remove this. No, if I remove this and click it again, you notice that it doesn't have that overlay. Awesome. So backdrop is an included attribute that popover has, and you can do that by itself.
Is that supported in all browsers? I missed that part.
Popover is also supported in all browsers. Backdrop, I will have to confirm, but I think because it's inbuilt with popover, like popover open and backdrop should also be supported too.
That's incredible.
On comment, what the hell?
Wow.
All right, more questions.
No, actually, we're kind of done.
Clearly, I'm greedy.
But yeah, but Jemima's around. Everybody, give her a huge round of applause. Thank you again, Jemima.
Thank you so much. All right. Oh, I can actually leave this here because Kateryna is up next.
Wow, so the beginning of that talk was really like the Olympics level of improvisation, right? Like, don't you hate it when like tech does not work? I can't stand when tech does not work, when it comes in my way. And speaking of things not working, by show of hands, and keep your hand up, who here cares about accessibility? All right, keep your hand up if you believe that accessibility is hard. Okay, so everybody that did not keep their hand, you can just leave because you will not learn anything. But it's actually true. Like, accessibility is hard, or at least feels hard. It feels like that realm of knowledge that, just a few people know about. But fortunately, we have Kateryna Porshnieva here with us. She's a lead at Buffer, and she's going to tell us how we can demystify accessibility in React. So give it up for Kateryna.
Hello, everyone. I think accessibility has been mentioned a lot. So I'm really excited to extend on some of the things that Jemima mentioned, for example, in my talk. But first, we'll be using quite a lot of audio because we will be listening to the screen reader. So let's do a sound check, and you will tell me how the volume feels, okay?
Sound check.
Is it good? Maybe a little bit louder. It was good? Okay. A little bit louder.
Sound check.
Yeah? Perfect. Okay, but then we can start. My talk is about accessibility. Are you ready to learn more about accessibility? Yes? Give it up. And accessibility in general, it's in the name. It's all about access. It is about removing and preventing barriers for access for people with disabilities. And you're likely familiar with a lot of accessibility features in the public space. We have elevators, curb cuts, ramps, sliding doors, all of these things that beep when you enter the crosswalk. They all help to remove barriers for people with disabilities. But similarly to how curbs can be challenging for somebody using a wheelchair, a lot of the features in our digital products can create barriers for people with disabilities who are using assistive technology. They're using tools like a screen reader, been mentioned a lot, but also there's other, like Braille keyboard, different switch devices, sip and puff tubes, voice control, and so on. And in this talk, I will cover some of the basics of accessibility. So then we will explore several examples on how we can avoid creating accessibility bottlenecks and some of those barriers for people with disabilities. But first, hello, bonjour. I'm super happy to be here in Paris. I'm Kateryna, I'm Ukrainian, I live in Estonia. This is me with my dog. Just a week ago, you see how cold it is in Estonia. So I'm actually really happy and enjoying the sun and warmth here in Paris. I work remotely at Buffer. I lead our front-end team. I really hope to share some of things I love about accessibility. But we have quite a lot of content to cover, so let's get started. But first, I want to start with some of the foundations. And all of these should help us to understand a lot of the examples I will be showing later a lot deeper. So on the web, everything starts with HTML, right? Browser receives it, and when the web pages get rendered, it parses it and transforms it into the DOM tree, which then is turned into the visual UI that user can see and interact with. However, in parallel to this process, browser also builds an accessibility tree. This is kind of a subset of the DOM tree, which contains all of the important accessibility information about elements on the page, which is then exposed to assistive technology like a screen reader and is used to navigate and interact with a page. But I think it's a lot easier to understand this when looking at the example. For this HTML page, accessibility tree will look something like this. Note that not all of the HTML elements are directly one-on-one mapped into the accessibility tree. For example, this div that we use for styling is emitted, and each element within the accessibility tree has its role, which describes what kind of element it is, what is its purpose, and an accessible name, which describes it on the page. In case of the button here, it is inferred from its content, right? It has a start label inside. Additionally, it can contain a lot of other attributes that describe it further or communicate its state. Like we saw, for example, open or closed for the popover. It can be also level of the heading, and so on. And we can access all of this information within the accessibility tree in the web browser. It already supported in the Chrome DevTools. You can see a lot of this information in the accessibility tab for individual elements, but you can also turn on the full page accessibility tree to see it all inside the DevTools, which can be super useful for debugging and understanding how things work. Now, this accessibility tree gets exposed to assistive technology by the browser and will be used to navigate the page. Let's see, or rather hear, in this case, what that might look like.
Page. Web content. Heading level 1. Hello. Waving hand. Image. Main. Let's learn about accessibility. Start. Button.
As you can see, screen reader announces information straight from the accessibility tree. It uses the accessible role that we just discussed, an accessible name, to describe elements on the page. And while in this example, I was just kind of going through elements sequentially, in reality, that often is not really realistic because we have pages with so many different elements. So screen reader users have a lot of shortcuts to navigate pages by headings, different landmarks, links, and so on. And this is exactly why using semantic HTML elements is so important. Semantics convey meaning. And in HTML, we have over 100 different HTML elements that come built in with a lot of semantic roles, states, and other attributes that are already embedded in the accessibility tree and by default supported in the assistive technology. And by using them, we can get a lot of the built-in behaviors for free, like in the details element you just saw in the previous talk. And also, they are a lot more accessible by design. However, for modern UIs, sometimes native HTML is not enough. We might have cases where this functionality is not maybe full supported in HTML yet or doesn't exist. And for those cases, we can use ARIA. ARIA stands for Accessible Rich Internet Applications, quite a mouthful. But it's basically a spec that defines a set of HTML attributes that we can use that give us granular control over accessibility tree. We have things like role. With role, we can override an accessible role of the element. However, it is important to note that ARIA provides just semantics, right? So it just goes into the accessibility tree in a way and changes semantic meaning, but doesn't change the behavior or appearance in any way. So we could, let's say, give a role of a button to the div, and yes, it will go and change it within the accessibility tree, but it won't make an actual pressable and focusable button out of this div. We would need to do it ourselves by writing a lot of JavaScript, usually, and custom CSS. And you can see that it actually takes quite a lot to just build a button. So in most of the cases, it is easier and more accessible to use native HTML. It is even noted in the ARIA spec. The first rule of ARIA essentially says that don't use ARIA unless you absolutely have to. However, where ARIA shines is implementing patterns that don't exist in native HTML. Things like combo boxes, tabs, tooltips, toolbars, feed elements, and so on. Additionally to roles, it also provides a bunch of other attributes to communicate the element, information about the element or its state that we can use. In a way, using ARIA is kind of like performing precision surgery on the accessibility tree. It gives us direct control, but it also comes with a great responsibility. In a way, using ARIA is like a promise. You're promising that this something is supposed to behave like a button, and it's important to fulfill that promise. And the research shows that pages that use ARIA on average have a lot more accessibility errors and violations than pages without, which just shows that with this amount of control, it's easy to mess things up. So we need to make sure we use ARIA only where necessary and rely and implement the behaviors as expected. Now that we've talked a little bit about how assistive technology interacts with the web pages, about accessibility tree, semantic HTML, and ARIA, we are ready to dive into some of the examples I wanted to cover. But first, a water break. Oh. Oh. Thank you. This is very reinforcing. And the first example I wanted to cover is quite simple, but we'll see that there's quite a lot of depth in there as well. And these icon buttons. We use icon buttons a lot, right? In general, if we have a button with an icon, icon often serves a purely decorative purpose, right? This button already has a label edit post. However, the icon itself might be actually announced to the user by the screen reader. And because it doesn't actually serve any purpose, it can sound quite confusing. So to prevent it, we can hide it from the accessibility tree using the ARIA hidden attribute. Basically, anything that is enclosed with this attribute will be excluded from the accessibility tree. So it's super helpful for anything that is purely decorative or doesn't need to be included, or you have another way to communicate information accessibly to the user, like in this button here. However, in modern UIs, we have a lot of buttons and a lot of actions. We often use buttons without any label at all and rely on the context and users' understanding of general patterns in the UI to understand their purpose. In order to implement this button, it actually wouldn't have any label at all, right? Because we already hid the icon. It's not very descriptive. There's nothing to announce this button by.
Button.
Imagine having all UI is just button, 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 and you don't know what it does. So we need a way to set the accessible name for some of these elements. One way to do this is we could use ARIA label attributes. As you remember, it will just go into the accessibility tree, and basically ARIA label just overrides an accessible name. So yes, it will work. However, ARIA label has some limitations. For example, it doesn't get translated if the translation feature is on. And users of assistive technology can also rely on the translation feature in order to interact with the web pages. And remembering again the rule of ARIA, right? Can we do it without ARIA at all? Let's see. And yes, we can. So there's this technique called visually hidden, or you might have seen SR only classes in Tailwind, for example. And it basically hides element from the visual UI. It is a CSS snippet that is commonly used for this. What it does is kind of just shrinks the element and hides it out of the view. Because if you use our usual hiding technique like display none, it would actually exclude elements from the accessibility tree as well. So we need kind of hacks like this in order to hide element visually, but still leave it present within the accessibility tree. So in that case, our button has a legitimate label, and we're using HTML feature and following the first rule of ARIA by not using it, and will be properly announced like this.
Edit post button.
This is a very common pattern. I personally use visually hidden a lot when developing the application. So in React, I would recommend extracting it in a separate component to make it easier to reuse and make the code a little bit more readable. Now, by implementing the icon buttons, we learned how to hide things in two ways. We learned how to hide things from the accessibility tree using ARIA hidden, and we learned how to hide things from the visual UI by leaving them in the accessibility using the visually hidden technique. Another important consideration is handling focus. So by default, browsers provide the focus outline for all interactive elements. However, often, and because these don't match, let's say, the aesthetics of the design, they're completely removed or replaced with something that is barely distinguishable. It is important for the focus outline to be very visible, because imagine interacting with the web page without seeing a mouse, right? This can be quite tough. So instead, we can create our own focus outlines. We can customize it. I made it pink to give it something little extra. But also, CSS already is very well supported, has focus visible pseudo-class. It is very well supported, and it basically just allows us to keep the UI aesthetics for all of the mouse users, because you know sometimes when you click, the focus outline is left on that button, but still leaves it functional and legible for the keyboard users. So if I would use a mouse, I wouldn't see the focus outline, but if I would start navigating with a tab, I would see it, which is kind of gives us best of both worlds and is a really nice CSS pseudo-class. Now let's look in a little bit more complicated focus management scenario. So it is a common pattern in the UI to, let's say, display actions on hover, right? Our modern UIs are so complex that we need to hide things and display them when they're needed. To implement it, we often would use absolute positioning and put opacity to 0, and then when the element, let's say, is hovered, we will switch it to 1, right? Common thing. However, there is a problem. If we try now to navigating it with the keyboard, the buttons will actually gain focus, right? But it won't be visible, which makes it hard to understand what is actually in focus for somebody who relies on the keyboard. You see here, right? They're kind of actually gaining the focus, but we just don't see it because it is hidden. So one way to do it is we could not apply the opacity 0 when there is no focus. However, it will also worsen experience for the mouse users, because now if I try to navigate this with a mouse, and then remove my mouse from the cart, they will kind of stay in there. However, there is no this focus visible within yet. However, it's something that would be very useful. But we can use the has here in order to find if there's any element inside the action that has focus visible, and only then apply opacity. And this works. Now we are able to navigate via keyboard, but then also the aesthetics are preserved for all of the mouse users. Has is also one of my favorite newer features in CSS. However, we also need to think a little bit more about different types of devices and interactions. So let's say we're using a touch device, and they wouldn't be able to access the actions in any other case. So we can fix this with one easy change. We can just wrap it with a media query, hover. So if any of the inputs of your computer supports hover functionality, in that case, we can these styles won't be applied. And we can then provide a fallback. And this way, we can support both the hover interactions and make it also more responsive for any mobile devices or any other devices that don't, let's say, use a mouse. Now that we've talked a little bit about icon buttons and making buttons accessible, let's talk more about accessible text inputs. So generally, inputs need labels, right? We need something to identify them. Because imagine filling out a form like this. It seems confusing, right? Unfortunately, this is close to an experience for a lot of people using assistive technology if we don't label inputs properly. We know that there's an HTML, there's a label element that we can use, and if we put it somewhere near the input, it will already visually convey the information. But if you listen to the screen reader,
Edit text, blank.
yeah, not very useful, right? To understand why, let's look into the accessibility tree. We can see that this input currently doesn't have an accessible name. This happens because screen reader doesn't recognize that this label is actually connected to this input. They exist as a completely different HTML elements. So in order to fix it, we need to explicitly connect them using for and ID attributes. In React, we do HTML4 instead. And now contents of the label will be used as an accessible name for the input.
Username, edit text.
Great, that works. We can also bind them implicitly by wrapping label around the input. However, this method is generally a little bit less supported by different versions of the screen readers. So even if you're doing something like this, it's better to still bind them explicitly using for and ID attributes. However, there's still in modern UIs some cases where you might not want to have a visual label near the input and rely on other ways to communicate input's purpose. So let's say we wanted to implement, we still wanted to provide this input without using a visual label. We can rely on our visually hidden component from before. So before it was just using a span with visually hidden class that applied that CSS snippet. We can make it a lot more flexible by adding our ability to preserve and change semantics. So what we could do is use what is known as polymorphism, right? In React, we can do it with an as prop or sometimes component prop or as child, as for example Radix uses. And basically adding ability to customize the semantic element, this would be rendered as. And then we can provide an accessible label like that using our visually hidden component. This can be useful for like search inputs where you might not need to provide a visual label. However, of course, in all cases, it's better to opt for the visual label instead. But generally, if we talk about labels, it's good to keep them clear and concise. But sometimes we want to provide additional information to the user, like different hints or instructions or description of the control, like this. To implement it, we can place some text underneath the input. And it will already visually look good. But again, we have the same problem. Because it is not connected to the input, it might be overlooked by the screen readers. And also, some of the screen readers have the form mode. So basically, as soon as the user enters the form, they're changing their navigation strategy to prioritize interactive elements. So everything that is non-interactive may be completely omitted. When we learned that all elements in the accessibility tree can have an accessible role and name and other attributes, I didn't mention, but they also can have an accessible description, which is usually empty by default. And we can set it using ARIA. We can use ARIA described by attribute and connected by ID to our input. And then contents of this description will be used to set the description within the accessibility tree and will be announced to the user, like so.
Username, edit text. Must be between 3 and 20 characters long.
As you have noticed here, for the accessibility purposes, we generally need to use IDs a lot. They are really useful to tie and connect different elements together. However, IDs also need to be unique on the page, so it can be quite challenging. And to make it easier in React, there is a super useful hook called useID. And if you use it, it will just generate unique ID for your input that you can use for accessibility purposes. Like here, we can generate an ID for our input, then use the same to compile the hint ID, and then connect different elements together. It's super useful for your design system components or anywhere you need a unique ID. Now that we've learned how to label inputs and provide descriptions for them, let's look at validation. Because the way that we validate and provide out kind of feedback to the users can really make or break experience of interacting with the form. In forms, we generally often have a combination of required and optional fields, and it's important to communicate to the user which is which. The most common way to do that is using the required kind of asterisk symbol near the label. Let's see how we can implement something like that accessibly. So let's say we put an asterisk in our label, but if we go listen to the screener, it will actually say something like this.
Username star, edit text.
So now our username is a star, right? It actually is an issue, same like we had with the icons before, with any elements like different separators that we might use that are there only for purely decorative purpose. We can apply the same technique here and just hide it from the accessibility tree. Now we have the visual cue, right? We have that rest asterisk that conveys the information visually. But we still need a way to tell the assistive technology that this field is required. If you're relying on the native HTML validation, we can use required true, right? It will already say username required edit text, which is great. But often in modern UIs specifically, we might want to implement our own validation instead to control this experience a lot more. So instead of the native HTML validation like this, we want to implement something custom, something that we have a lot more control about. So let's see how we can do that. And this is actually a perfect use case for ARIA, right? We want to implement something of our own, but we want to still provide semantics in the accessibility tree. So we can use ARIA required attribute for that, which will still be communicated to the user, like so.
Username, required edit text.
But it won't kick off the native HTML validation, which might not be always what we want. And while generally marking required fields is a very common practice, we might also want to consider marking optional fields instead. This way, forms visually are perceived a little bit less threatening and can make it a little bit easier to fill for users. But if you do it like this, I would still recommend leaving that ARIA required semantic attribute on and just adding an optional label for the optional fields. Now that we've turned off the native HTML validation, we need to implement our own. And it is important with how we surface errors to the users, and it can have big impact on the user experience. So let's say you want to display an error message underneath the input like this, and there is one gotcha about error messages in general that I wanted to cover, and it is about using color. So we generally use color a lot in the interfaces. Green for success, check marks, red for errors, and so on. And while there's nothing wrong with that, we need to remember that different people perceive color differently. So for some people with color blindness, this might look almost exactly the same, which can make it harder for them to understand what this message is trying to convey. So already displaying a small icon, like a check mark or like an error marker, would already make it a lot more universal for more users. And green late color blindness is actually very common. So to make it a lot more universal, we can just add here an additional indication on the input. And let's see how we can implement it in React. So now we have that kind of visual cue, right? We have the red border for the input, we display a message. We also need to provide a semantic cue as well. There is another ARIA attribute that we can use that is called ARIA invalid, and it signifies that this input has invalid data. And then this information will be surfaced in the accessibility tree. One tip in here is that we can use all of these attributes for the styling purposes in our CSS to, let's say, add an icon and change the border. I really like this approach because it is easier. I don't need an additional CSS class, but it also makes sure that our semantic cues in the accessibility tree and visual cues are always in sync. Now that we've marked it as invalid, we also need to communicate an error message somehow as well. Let's display something underneath. And here, there's actually an ARIA attribute called ARIA error message that exists specifically for this purpose. And if we connect, it might get announced. But the gotcha here is that screen readers are different, and they implement the standard a little bit differently. And while ARIA error message existed for a pretty long while, it's still not very widely supported. So while its support in different screen readers is still developing, we can use accessible description for the error messages as well. So ARIA described by can actually accept multiple IDs. So we are providing both the hint and an error here, and we'll concatenate them when announcing to the user. And now let's hear what the screen reader says.
Username, invalid data, edit text. This username is taken.
Great. Right, you see, notice how it says invalid data. It is because of the ARIA invalid attribute, and then it announced the description. Now here we've learned about making our inputs accessible, using ARIA to set accessible description and expose validation errors. And the last example I wanted to cover is notifications and making notifications accessible. Thank you. So let's start. Notifications in visual medium generally come naturally, right? You see something changing on the screen, the more important the message is, the more visually prominent it becomes. And because you see changes on the screen, visually you immediately notice it. However, the screen reader works with the page sequentially, so it cannot be focused in multiple places at once. And therefore, we need a different way of notifying users of the screen reader about any important notifications. Which brings me to another really powerful feature of ARIA called live regions. Live regions allow us to define certain areas within the page as live, and then they will be watched. And whenever something in that place changes, the screen reader will be notified and can announce this change to the user without losing its current position. So we can use it for any important status information updates or error messages. It can be set using ARIA Live attributes, which support several settings. It can be polite, meaning that it will wait for speech to finish before announcing the change, or it can be assertive, meaning that it will interrupt the speech for the announcement. If you have something like toast or notifications region within your page, something like this, we can add, let's say, ARIA polite to each notification, and therefore it will be announced to the user. Another way to do it is also using the role attributes. So when we use the role, it already comes embedded with other accessibility information. And therefore, when you use the role status, for example, it will already preset ARIA Live to polite for us under the hood, along with the ARIA atomic property, which will make sure the whole message always gets announced, even if the part of it changes. Now, the screen reader user can get notified like this.
Delete button. Item was deleted.
And we can use the same approach for communicating errors as well, like here. We just need to set ARIA Live attributes to assertive on our error message. Or we can use role alert, which will set it for us under the hood. And then when I'm signing up, and let's say we receive an error from the server, we can announce it like this.
Sign in button. Sign in failed. Username or password are incorrect.
Another aspect with how we can use the live regions is for field validation as well. So when we talked about fields, we used accessible description to connect them to the input. However, it would still, in order to hear that, it would still require the user to actually physically navigate into the input to see what has changed. And sometimes we want to provide more instant feedback to help them be more successful when filling out our form, like this. We can implement it by setting the role alert to the error message or the status message under our form, and therefore, when something changes there, it will get announced to the user. Now let's see all of this coming together in the little screen reader demo.
Username, required edit text. Username is too short. A-M-B-E-R-E-C-H. This username is taken. 2. Username is available. Email address, required menu pop-up edit text email. Display name, required menu pop-up edit text. Kateryna Porshnieva, window. Website, edit text URL. About you, edit text. Sign up, button. Sign up failed. Email field is invalid. About you, website, Kateryna email address, k.porshnieva@gmail.com, window. Web, about you, sign up, button. Account created. Check your email for confirmation.
As you can see, with all of these different pieces that we worked on together, it kind of resulted in a more seamless experience of filling out the form using the screen reader. Now, before we finish, the last thing I wanted to cover is about how to test for accessibility and how to ensure what we build is actually accessible. There are some ways to test for accessibility automatically, right? So there's Axe DevTools that can provide you some accessibility warnings within the browser and scan the page. Also, Lighthouse has some accessibility auditing embedded into it. If you want to get some hints and prompts within your editor, there's also an ESLint plugin called JS6 Ally. And by the way, A11Y kind of stands for accessibility. And it then can hint you, for example, about when you're validating the page or you're using kind of ARIA labels incorrectly. So this is where you can see the Axe DevTools. You can download them for your browser. You can just install this plugin. It supports all of these different rules to make sure that you're not using ARIA incorrectly. However, we can only take us as far with automated testing tools. They can't really see the user experience that we are providing. And I think one really good way to ensure that what you build is accessible is within your normal automation testing. Right? So you probably already write some integration and unit tests for your application using something like testing library. Maybe you're using a Playwright. And we can make our tests kind of a little bit more kind of to check accessibility as well. Because if you think about it, the test framework interacts with your page kind of similarly to how the screen reader would. It doesn't see the UI. And we can use it to our advantage by prioritizing using semantic selectors and matchers. For example, instead of reaching for something that is like get by test ID or get by text, we can use things like get by label text in order to actually use label that is tied to that input in order to get it within our test. We can also use get by role for things like alerts or buttons. So instead of doing test IDs or text, this will already automatically check that the correct roles and attributes are set within the accessibility tree. We can also access all of those attributes using specific matchers. Right? So for example, there's semantic matchers for to be required. So we can check that everything that is required and everything is not supposed to be is not. We can check that some things are invalid. This already will check for that ARIA invalid attribute. And we can do the same with invalid as well. And we can use also to have accessible description to match that there is an accessible description matched to the input. And so by pushing ourselves to find more semantic ways to test your logic, we can both have more reliable automated tests and push ourselves to learn a little bit more about accessibility and identify any gaps. But of course, this still is not the same as actually using assistive technology. So if you haven't ever used the screen reader before, I really encourage you to try it. And for example, if you have an iOS, if you have an iPhone or you have a Mac, it already comes built in with the voiceover. You just need to go and turn on in settings. For Windows, you can use NVDA or JAWS, and there's a talkback on Android. I know that the first experience of using Screener can be quite confusing and maybe scary. I would really recommend this video series on YouTube by Rob Dodson, and there's specific tutorials on how to use different screeners. If you have a Mac, and I think a lot of us probably do, there's also really good tutorial when you start using the voiceover that walks you through a lot of its features. But naturally, even if you do use the screen reader, the way that you use the screen reader will be very different from how the actual person with disability would, because they rely on screen reader in their day-to-day. They're a lot more proficient with it and know a lot of its quirks. So if you have ability to engage with users with disabilities of your product or your website, I really recommend you do. It's something that we've done quite a lot in Buffer, and it's been super insightful experience to learn how what we built is kind of interacted with by different customers. If you don't, there's also services like Fable that can connect you to people with disabilities, and they can test your product and provide you really good feedback and input on what needs to be improved. As the last thing I want to note is that accessibility is not black and white, right? It's not completely accessible, it's fully accessible. And by learning more and making small improvements, we can generally move towards a more accessible and inclusive web for everybody. I have a little bit more resources about testing accessibility, different tools, links, and references. You can see it in this QR code to dive a little bit deeper into the topics, because accessibility is quite nuanced and complex, and there is often not one right solution to everything. I really recommend you go dive into some of the specifications and different examples, and I've listed some on this page. And yeah, thank you so much for listening. I hope you enjoyed it.